Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com and the topic of kinematics. The title is Matching Pairs, Speed, Distance, and Time. So the main idea of this concept builder is to understand this equation. And this equation is for average speed. We see average speed is s. Often this equation is velocity, average velocity, but here we're not going to get into the differences between speed and velocity. So average speed, which is measured in meters per second, it's always a distance over a time, like miles per hour would be fine, but this is using the common MKS system of meters per second. How many meters does something travel in each second on average? The distance, d, is the distance it travels in meters, and time, t, is the time it travels in seconds. We may have to do some algebra to rearrange this equation, but that's the base equation that we'll start with for each problem. Let's get into the apprentice and master level, and then we got one more concept to hit before we get to the wizard level. First, here in the apprentice level, we can see this is what the problems are going to look like. It's actually a matching, but if you can calculate these things, you can find the one that matches with them. So one tile will say something like distance is 24 meters and time equals 3 seconds. Not exactly a word problem, it kind of just gives you d equals 24 meters and t equals 3 seconds. I'm going to put a link here to a video I made on a 5-step method for solving physics problems. So take a look at that. There are actually 2 videos. Take a look at them if you need some help into how to go about writing down a way to help you through the problems. Okay, so we got our unknowns there. We're looking for speed. It won't say calculate average speed, but if you have distance and time, if you have these 2 things, the only thing left to be calculating is speed. And you'll see that there are other little things to match with it where it says s equals something. Okay, so then we write down the equation we're using. We don't need to rearrange it because we're already solving for s. So then we just plug in, okay, in case you aren't super familiar with this, I'll just mention it quickly here, but if you need more, check that video that I linked earlier. Distance is 24 meters. D equals 24 meters. We can see D is in the numerator here. And so we'll put 24 meters in the numerator. Then we can see that T equals 3 seconds. T is in the denominator. So 3 seconds goes in the denominator. If you're familiar with fractions, which I hope you are, and if not, please do some research on your own. But fractions, that you take the numerator and divide by the denominator. So you take your calculator, 24 divided by 3. Many of you can do that in your head. You get 8. And then the units, we have meters. We have meters here in the numerator, seconds here in the denominator, so we get meters per second. All right. The second type of problem you'll see in the apprentice level gives you distance and speed, average speed. And so if you see that, then the only thing left to calculate is time, and you'll match it up with a box that has time. So let's go ahead and write that down. D equals 24 meters. Speed, average speed equals 3 meters per second, and t equals our unknown. We write down our equation. S equals d over t. Now this time we have to rearrange because we're solving for t. You see t is in the denominator. I'm going to write it over here to do my rearranging. T is in the denominator. We never want to solve for something that's in the denominator. So multiply both sides by t. That'll get t out of the denominator. Then we have t times s equals d. Well, if we want to solve for t, we're going to have to get rid of s. That means dividing by s. If we do it to one side, we have to do it to the other. So divide that side by s. Extend our dividing line there. So these s's cancel. And we're left with t equals d over s. In case you had trouble seeing that, t was the only thing left on this side of the equation. We had d in the numerator. The t had canceled out. D was in the numerator, and S was in the denominator. So we rearrange and get an equation like that. If we plug into that now, we plug D into the numerator and S into the denominator. We see that we get T equals, again, 24 divided by 3, which is 8. This time our units, the meters cancel out. This seconds is in the denominator. I like to say if you divide by 1 over S, that's like multiplying by S, right? Multiplying by the reciprocal. And so that will be seconds, which we would expect time to be in seconds. All right, let's move on to the apprentice level. The apprentice level is similar. You will see ones just like we had the time before, so I'm not going to calculate that again. But where you're given distance and time, and you have to calculate the average speed. But now you have ones where you're given speed and time, and you have to calculate distance. So let's step through that since that's a different example. So speed we see is 3 meters per second. Time is 6 seconds. And distance is our unknown. So our equation S equals D over T. We come over here and we write S equals D over T. To solve for distance, distance is already in the numerator. So all we have to do is get it by itself. We're dividing by T, so if we want to cancel that out, we multiply both sides by T. Okay, or you could say since there's a T in the denominator, we want to put a T in the numerator to cancel it out, because T divided by T is 1, we can get rid of it, and we're left with T times S equals D. Now, most of us prefer the unknown to be on the left, so I'm just going to write it the other way around. Okay, if A equals B, B equals A, associative property, I believe, from geometry. Okay, so here we have the distance equals time times speed. All right, so now we just plug in D equals, and I like putting these in parentheses. Here's the time, 6 seconds, and here's the speed, 3 meters per second. So we're going to multiply 3 times 6, and D equals 18. We have a seconds in the numerator, canceling with a seconds in the denominator. That leaves us with meters as our final answer. So you'd look for a little box. If you saw this in one box, you'd look for another little box that looked like that. All right, moving on to our last concept before we hit the wizard level. So you will once again need to be able to use your average speed equation, but you'll also have to understand what happens if something is undergoing constant acceleration. Okay, so what will happen, I believe, in all of these examples is something's going to start from rest. This is the initial speed. This is the final speed. Like in a car race, the cars have to start at rest. Well, I guess I don't know much about car races because I'm not a NASCAR fan. But I would imagine just like a track meet, okay, person has to start from rest. Okay, so this is going to be 0. So you could imagine this, you could imagine this just disappearing. It's 0. Okay, so then we see that the final velocity, if we want to solve for that, we could just multiply both sides by 2, and we get that 2 times the average velocity is the final velocity, or that the average velocity is half of the final velocity. Because it starts at 0, and if it's in uniform or constant acceleration, then it's going 1 mile per hour, 2 mile per hour. Oh, let's do meters per second. 1 meter per second, 2 meters per second, 3 meters per second, constantly. So however fast it gets at the end, the middle is halfway there. Okay, and that's the concept you're going to need for the final section here. Let's get right into it. Okay, so you'll see something like starts at rest. That tells you there's uniform acceleration. By the way, the wizard level will have some that are like the first two, the apprentice and master level. But since we've already got that down, just be aware there'll be some like that. But these are the new types. Starts at rest, travels 48 meters in 12 seconds. Okay, well, we were given the distance. See, now you have to kind of figure it out. The key is look at meters. Meters is a measurement of distance. Okay, so distance is 48. Then we see 12 seconds. Well, seconds is a measurement of time. So that means the average speed is an unknown. We also don't know the final speed. Okay, and this problem could have a calculation that's average speed matches up with it, one that says the average speed is yada yada, or one that says the final speed is something. So let's calculate both of those. So we see S average equals D over T. Okay, well, that was our equation for average speed. We didn't used to write in the average, but since we have a final speed, let's write it in. So S average, write it a little bit better there, equals 48 meters divided by 12 seconds. S average is 4 meters per second. Okay, well, remember it's speeding up from rest, so it's going 1, 2, 3, 4, and that's the average. It's also kind of halfway in between if it's accelerating at uniform, which is the assumption for all of these, even though it won't necessarily state it speeds up at average. But if it says it starts at rest, it must be speeding up, because if it stayed at rest, it wouldn't go anywhere, right? Okay, so therefore, we know that the final speed equals twice the average speed. Okay, and so we just plug in 2 times 4 meters per second, and that gives us 8 meters per second is the final speed. All right, I'm going to have to clear that to work on the next one. Actually, we can start working. No, I can't, because then I'd have to erase it partway through. So that's the final one. If you're given a distance and a time, then calculate both of the speeds. In the next problem here, we are once again set it steadily. Now it actually tells us, that's nice. Speeds up from rest. From rest, that's key. Starts out at 0. And we're given something in meters per second. Well, 12 meters per second, that's going to be a speed. And it's saying that it goes to that fast. It doesn't say it averages that. It says it goes to that. That means it's our final speed. We're going to end up at that speed, 12 meters per second. And we've got the time equals 3 seconds. So what are we missing? We don't know what D is, and we don't know what S average is. Okay, well, we know that we can figure out S average from the final velocity. S average equals S final divided by 2, right? Because if it gets to 12 by the end, it must have been at 6 halfway through, right? We plug in 12 meters per second divided by 2 equals 6 meters per second. Okay, so the average speed is 6 meters per second. Well, now we can go back to our equation, S equals D over T. We can solve for D. It's already in the numerator, so we multiply both sides by T, and we get D equals ST like we did a few slides back. Once again, the T's cancel, and we get D equals T times S or S times T. It doesn't matter which way you multiply things. So then let's plug those in. Once again, this is the equation for average speed. Okay, so average speed was 6 meters per second times the time. The time was 3, that was quite a 3 seconds. Our seconds numerator, seconds denominator, they cancel, and we get 3 times 6, or 6 times 3, which is 18 meters is our final distance. And once again, you could be pairing this up with a calculation of average speed, or you could be pairing that up with a distance. So look closely. All right, we'll have fun puzzling that out. And if you have any questions, leave them in the comments below. If you enjoyed the video and it helps you out, please click that like and subscribe button. And we'll catch you the next time on the scientific adventures of Beardman.